The state of the molecules after microwaving or boiling the sample is what determines the absorbance that the spectrometer will measure, and therefore the frequencies that the sample absorbs. When the sample is heated, the pigments in the sample start to become pale as time passes. The spectrum therefore reflects less yellow. Consequently, depending on the method through which the sample is heated, the velocity of the chemical reaction of the sample differs. The microwave oven resulted being the most efficient when heating up the pineapple sample. Nevertheless, if the pineapple sample was exposed for a longer period of time on the burner, the rate of the chemical change with the burner would reach that which is achieved by the microwave oven in less time.
The microwaved and heated samples were placed into a spectrometer, which measured absorbance versus wavelength. According to Beer's law, the relationship between concentration and absorbance of visible light is directly proportional. This means that if concentration increases, absorbance increases as well. It is also directly proportional to the length of the cuvette, or the length of the light path. Therefore, it can be concluded that if the absorbance of a substance decreases, the concentration of beta-carotene decreases as well. This relationship occurs because when there is greater concentration, light has more particles to interact with, and therefore has a greater absorbance. Beta-carotene is the molecule that gives orange or yellow fruits and vegetables their color. It belongs to the family of carotenoids, which were first isolated in the 19th century and have been used in food colorants since 1950. The orange color of beta-carotene is due to the long chain of alternating, conjugating double bonds in the molecule. Pineapple is black inside. However, the conjugated electrons sway from side to side, which causes the blue light that the pineapple absorbs to be reflected as the color yellow. So, when the food is exposed to microwaves and heat, the structure of the molecule is damaged, which would mean it is harder for it to reflect yellow. So, theoretically, the color of the pineapple juice should change as it is exposed to heat or microwaves. However, with the experiment, it was seen how caramelization caused the juice to brown and darken. The result of the experiment turned out to be inconclusive. Microwaving the pineapple juice showed an increase in absorbance, therefore an increase in concentration, while heating the pineapple showed a decrease in absorbance compared to the control sample. These results indicate that compared with the control sample, the microwave increases the absorbance of the pineapple juice, meaning that the concentration of beta-carotene increases as well. This is due to the process of caramelization that the sugars in the juice undergo in the microwave. However, the caramelization led to inconclusive readings from the spectrometer because it led to browning. An important observation is that in the last 4 microwave trials, the volume decreased significantly. In the last 2, the volume decreased by nearly half.